So while we were having a conversation earlier, outside of this podcast, obviously, Ginger, you mentioned that now math in elementary level is taught differently. And what is the reason for that?
Well, so for such a long time, other countries have taught math in a way that promotes thinking and not so many procedural aspects of performing an addition problem or performing a subtraction problem. In the United States, we adopted years ago the standard algorithm, where you line up all of your numbers and you carry the one. We're really not carrying one. We're either carrying a 10 or 100 or 1,000, depending on how large the number is. So after some studies and some national-wide tests in the United States, they started looking at why are countries like Australia or Singapore, why are those areas outperforming students in the United States? And so they started looking at how those students solved problems. And really today, the purpose behind teaching math a little bit differently is because, one, we know that developmentally it's appropriate. By that, I mean we use manipulatives. We follow something called the CRA or CPA, which means we move from the concrete to the representational to the abstract. That standard algorithm that you and I learned where, 3 plus 7 and you regroup and you carry your 1, but it's really a 10. All of those things are procedures. Whereas if I lay it out with concrete manipulatives, students can actually see that regrouping of the 10 or that regrouping of the 100 with the manipulatives in front of them. Then we move to something called pictorial or representation, where students are drawing it out and then moving to that abstract. But with that abstract, we're using the tools that we've learned. For example, if I have the number 563, we know that that's made up of 500, a 60, plus a 3. But are there other ways of saying that number? I could say it with a 500, I could say a 7 or a 50 and a 13. So being able to regroup those numbers and decompose it in different ways, that's really critical to helping our students understand those numbers. I wish I'd brought a little whiteboard because I could show you, but one example is when I, as a 5th grade teacher, if I wrote a problem like 100 minus 99, so many of our kids didn't even look at the numbers to see that the difference is 1. Instead, they went straight into the algorithm of regrouping to get to that same answer of 100 minus 99 is 1. And so that's a huge eye-opener for a teacher when you see students no longer thinking about the numbers, but just jumping straight into a procedure.
Yeah.
And so the way we're teaching our students is really about building them to a level of mental math. In my work as a trainer of teachers, if you will, or a coach for teachers, I oftentimes ask, how would you solve, and I, give a number, how would you solve this in your head using mental math? And so many people with their mental math, they still want to do that standard procedure to try to determine what that number is. But then by the time you finish, did I carry a 1 or did I carry a 2? Yeah. What number did I bring down? Because mentally we're trying to conform a procedure into something that doesn't make sense. But then you ask other people and they'll say, oh, well, I made a 10. Or I regrouped, I counted my 10s and then I just added on. Well, that's mental math. And we're trying to build that understanding of those numbers so that you can do more computation in your head and not rely on a procedure to figure out that 100 minus 99 is 1. And, you know, I would challenge any parent of an elementary age, you know, depending on what the grade level is, ask your child what that is and see what they do, or write it down on paper and see what they do. And if they jump straight to a procedure to solve that, then they really don't understand numbers and how they relate. And so as a math coach, we're really working hard to help children understand what those numbers are. And that involves counting forwards, counting backwards, being able to start at any number to count. And you know, if you have a first grader or even a kindergartner right now, you know, they're counting all the way up to 100, but, you know, a first grader should be able to count backwards from 100 starting at any number. So if I said count backwards from 87, are they understanding where that 87 fits into the realm of 0 to 100? Or do they have to go? And you'll see them, you know, bobbing their head or looking up at the sky like the ceiling is going to give you that answer, right?
Sure, yeah.
Or you see them under the table doing this. That means they don't have a firm understanding of where that 87, for example, fits into the realm of between 80 and 90.
Yeah. So is it a matter of practice that we have them do that at home, or how do we get them to get to that point?
So, one, ask the teacher, what resources can I use as the parent to support them at home? 2, take a look at the work that they're bringing home. See how they're solving those problems. And I've seen so many videos of parents complaining, are you kidding me? They have to break all this apart to be able to solve this problem? Well, and I have a YouTube channel where I kind of explain some of that. You can look me up, Ginger Abby Habib.
And I will also put it in the description so we have that.
Yeah, so we have those videos. But so I show in there how understanding the process of how those numbers relate and can be added or subtracted is very different from going back to that standard procedure that we spoke about, where I have no understanding. And the student who can break it apart, decompose those numbers, if you will, to be able to add a 60 and a 70 together, have a deeper understanding than just that rote algorithm. So I would say as the parent, you know, do some research, figure out, you know, how it's being taught. And it's in our state standards. I travel all over the United States doing trainings now, which is so exciting. And the issues that we have here at home are the same as other states, I'm finding. And so, but one of the things with that is in our state standards, it lines up for us as an educator how we need to teach that problem. So we're here in Texas, right? And the standard algorithm is not mentioned anywhere in the math standards until 4th grade. But yet, as a 2nd grade parent, when I see those things coming home, I want to jump right in and teach them the way I learned. But the way I learned, literally the way I learned, is not going to lead our students to a better understanding of math. It's not going to lead them to a better understanding of numbers. And it's not going to help them build that mental math understanding versus being able to see and build that problem. I use an example a lot of times in my trainings because I'll have teachers who will say, well, they can't carry around those manipulatives forever. No, they can't. But if I have seen a visual, I'm more likely to be able to go back in my brain to
Make that connection.
Make that connection, yes, absolutely, to what I'm learning and to what I'm seeing with the word problems or, just building it out. I have a better understanding now as a teacher, being very honest, than I did as a young student. I have a much better understanding of numbers than I do versus when I was young. I struggled with math.
Yeah.
I was the kid who didn't get, my mom would use flashcards to, for addition facts and subtraction facts. And I remember sitting on the couch with my mom and counting, trying to figure out, 9 minus 7 and 8, 9. Oh, it's 2. But I didn't understand on a continuum where those numbers fell to be able to understand that 7 is only 2 away from 9, or that 9 is only 1 away from 10, because I never had that visual. I was always taught that standard algorithm, and numbers just didn't make sense to me. I was the kid who my dad would call out, 9 times 3 in the car while he's driving, and I'm in the back seat going, I don't remember, right? I was that kid. And so I think as a teacher, it became really important for me to help students like me, who later went on to,
educate.
Yes, to be an educator and to teach math of all things. But it really opened my eyes, I think, as a learner, to help students be able to see and visualize and to be able to when you're multiplying, what are you multiplying and why are you multiplying? It's groups of something. Well, no one told me that.
Yeah.
No one explained how division works. It was just again, you just follow the motions and somehow you end up with a number, right? And so teaching math today it's a lot more visual. I would encourage parents to, take a hard look at that homework and really think about, how is this helping my child build an understanding of numbers, or numeracy as we call it, and how is this work going to build them into a place of a mental math and understanding. As a parent, cautioning parents from jumping in and wanting to teach them the way they learned, just to get it done. Oh, I know very well what happens at that kitchen table at night. But I know what happens at the kitchen table at night. I have a son. He's in graduate school now. He's graduating at the end of this year. Actually, he'll be a doctor of chiropractics. And I remember him crying at the table, I don't understand, or, just being frustrated with his own homework. Well, A, is he just tired and hungry because he's been working all day? Yeah. Or B, is it because he really doesn't understand? And if he really doesn't understand, then even myself as an educator, I want to take a step back and not interfere with the learning in the classroom, but support that learning. But when kids come in and say, my dad taught me another way to do this, or, my mom taught me another way, and I say, explain it to me. Mm-hmm. If they can explain it, have at it. But if they cannot explain it, they don't understand what's actually happening in those numbers, then that's where I have to take a step back and say, developmentally, you're not ready for that. There's a reason why that standard algorithm, it talks about using algorithms in our standards, but that standard algorithm that you and I grew up learning is not developmentally appropriate, really, until about 4th grade. Mm-hmm. And then students have a firm understanding of numbers, and they can see how they relate and what they're doing.
Mm-hmm. I think this is a huge eye-opener for me, because I have a kid who is in elementary, and she's a first grader right now, and the way she brings her homework and she talks about her math, and I would say that my husband is more involved with math than I am. I'm more involved with English, but I hear my husband ask her all the time, like different types of math questions. What is 80 plus 40? So she has to go beyond 100 because she realizes she understands hundreds, but then adding another 10, 20 to it. Or what he will do is just have her count some money. Can you add this together and see how fast she's counting? But I think the element of adding the visual to it, I thought I was the visual person, so that's why it helps me learn like that.
Right.
But I think it helps most people learn like that, and it's a part of our actual real education system. So it's good to know that I'm kind of sort of normal, that I learned that way. I have to make that connection.
Yes. Even our students who are not visual learners, a lot of times I'll have kids who, they're really high achievers, or maybe they've been identified as gifted and talented, and they'll say, I don't need to draw that out. Well, actually, the way our state assesses, because of the way our standards are written, a lot of times our standards, some of the standards will say represent fractions of, greater than a whole, or represent how to solve whatever the situation is. And the way it's assessed on our state assessment, they don't even want you to solve the problem. The question will say, which of the following best represents a way to show 8 times 3, for example. And if the student has not had experiences or understanding that representation, they're going to miss that problem every time. They're going to miss it. And just a keynote about those assessments, mathematically, I can solve that problem, and mathematically, I can come up with answers A, B, C, and D. So it's not as cut and dry as a lot of folks think, because we're really focused on analyzing, representing, and our students thinking beyond and using logical reasoning, which as a first grader, you think, reasoning? Oh, she can barely get from here to her room without, 5,000 distractions, right? Yeah. Well, thank goodness our first graders are not taking those state assessments, yes? But if they haven't had those experiences all along, then we're setting them up for failure later when the problem could have been solved very easily with an understanding, having that time, drawing it out, and, and having that understanding.
Yeah, absolutely. I think as parents, this is a good reminder for us to take that time and take the time to build now when they're younger at this age, as opposed to just trying to solve the problem for them.
Oh gosh.
And get them to just finish their homework or just finish it up and move on with the next thing. Because I'm guilty of that, I'll be very honest. Because I'm always thinking about the next thing. But as I'm, I would say, maturing in life, I'm learning to be more in the present, and that plays out in many different ways. Sure. If I'm more in the present, then I'm more just in that moment when I'm trying to help my daughter to finish her project, then I'm actually with her in the real sense, trying to help her, not just finish it up, but finish it up with a good understanding of what she's doing.
Homework, like I said, I spent my years at the kitchen table as the parent on the other side. Homework is meant to be an extension of the classroom, but homework is really meant to be a practice of what they've already learned in class. So if they are coming home with homework that is just blowing their mind, then I would just, reach out to the teacher and say, hey, struggled with homework last night, especially at the elementary age. It's different if it's isolated to one problem that they struggled with. Mm-hmm. That's different. But struggling with the whole assignment, then I would say, have that conversation with the child and pull out that math notebook, see what they've been learning and how they've been practicing this in class. And then reach out to the teacher. Don't try to overstep and do it for them, because at the end of the day, who is the student? You as the parent, or the student himself?
Yeah.
And it shows when a student comes back and mom or dad has done all the homework, sometimes in their handwriting, sometimes in the student's handwriting. But then you go to have that conversation and the child is very honest. My dad did this, I don't know how to do it. Well, how did you set your child up for success the next day? You sent them to school with a completed assignment, but a completed assignment without understanding is not any better than just not doing it. I get the effort was there, but mom and dad, you're not the student sitting in that classroom.
You're being very kind. Like, that's not the way you should be rolling.
Yeah, that's
It's inappropriate. Anyways, but then you're not helping your child.
No.
You're actually showing them that it's okay to do this cheating as well.
It's learned helplessness, really. I don't understand. We've seen the drama, right? I have as a parent. I don't get it. I don't understand. The teacher didn't explain it. Oh, really?
Yeah.
Really?
Yeah, and this is you bring a good point as to if they're not following your homework, what they should have already practiced, like the basics of it in the class, then basically what you're saying is it's not something that you're going to be teaching them for the first time.
No.
It's just practice.
Yes.
Or the next, or just the practice of it. So if they're struggling with the whole thing, then it's time to find out and speak with the teacher to understand what the reasons could be. Is it my child just getting tired at that point, or
Sure.
are they're just not following the teacher? Sometimes the kids, they're just getting phased out or just not following. So is it that, or is it just that they're not understanding math itself or a particular subject? Do they just don't have that interest? Because that could be it as well.
Sure.
Because we all have our interesting subjects or something that we're more interested in. So it's time to find out. And I love the way you put it, that who's the student, who's learning. So it's sort of like taking, for me as a parent, to take that step back and to see, not to step on my child's toes and not to step on my teacher's toes, and to let them both come together and solve it, rather than me coming in and saying, you can do it this way, you should do it this way. No, your child also has a different learning ability than you yourself as well.
For sure.
So they're at a different point in life. You cannot go back 20 years in your life or 30 years in life and think about how was I thinking as an elementary student, right? So
right.
It's time to take that step back and think like that.
Sure, absolutely. Helping them at home. I would say if you wanted to help your child at home, cook with them in the kitchen, measure, cups, ounces, teaspoons, teaspoons, that gets you into fractions and understanding of that, right? Have them count money with you, although know where the child is, because developmentally, we're not counting dollar bills in first grade. We're just counting coins and recognizing coins and understanding the value of a quarter versus a dime, right? So we're still looking at some of those things. Is the child ready to add numbers beyond 100? Well, in first grade, they only go up to 120. But the first grade standard says we're only adding within 100. And so, and they're adding groups of 10 more, 10 less is actually one of the standards, 1 more, 1 less. So, yes, as a parent, we always want to help our child, but especially with the little ones, count at home, count everything. We counted, when my son was little, we would open, his little book and we would count the butterflies. We would count the ladybugs. We would count how many people, how many friends are wearing glasses in the picture. How many tennis shoes do you see? Oh, this friend is wearing sandals. So, we counted everything, and not always starting at 1. being able to count, like I said a second ago, being able to count starting at any number, and moving forward and watching, your child dance across the ceiling as they get to 9 to be able to count up. Then that kind of helps. It supports what's going on at school, but it also values what they're learning in the classroom. Even at 4th grade or 5th grade, counting is very important. When was the last time you sat down and counted 1,000,000 of something? I haven't.
Never.
But, counting beyond those numbers, we assume that they understand those thousands and the 10,000s because of the number pattern, but do they really? But having those experiences to count and count beyond just starting at 1.
Yeah, and I think my key takeaway, and there's many here, but I'm just saying, in terms of counting, is that also have them count backwards, and starting at any number. Because I have never done that with my child. I've never done that with myself. I've never even thought about this in this manner. That how it puts the whole scenario together for them. If you actually just say count backwards from 87, I would like. That's incredible.
You gotta sit and you gotta think for a second. If you haven't done that for a while, one of the things that I work with teachers on is we did a lot of small group work with our students, meaning I've got a class of 22, or more than that in the upper grades. When I taught 5th grade one year, I had 33 students in my classroom. But I worked with my kids a lot in small groups, so that means I only have like 5 or 6 in front of me, and my other students are working in stations or working in groups. Counting with my students, we did a lot of counting forward, but I didn't necessarily say count forward starting at 54 and tell them to stop and then throw it in reverse and count backwards. Your brain doesn't work that way. So think of your car. If my car is in drive and I'm going, how do I get it into reverse? Do I hit park, or do I hit just reverse while I'm going forward? Does your car work in that way? No. So guess what? Your brain doesn't work that way either. So if I'm counting forward, then I'm going to take a little break, and we might just recognize some numbers, or, what is 27? It's made of a 20 and a 7. Can you think of another way to break 27 apart? It's made of a 19 and a 6. Ooh, it's made of an 18 and a 7, right? So getting our kids to be able to break numbers apart.
Yeah.
And then I would say, let's count backwards. And really, seeing where they are. Are they able to count backwards after 50, beyond the 50, or are they still within 1 to 50? And, you've got to meet them as a teacher. We met our students where they are. That's called differentiation. And it's not always the easiest task. But when we differentiate in the classroom, that means I'm meeting you where you are. If you're able to count beyond 50, then I'm going to work with you beyond 50. But if I have 5 other students over here who are still working within 1 to 20, for example, then I'm going to work with them separately, because my student who is working beyond 50 needs a different approach, needs additional support, support in a different way, because their learning is in a different place.
I really appreciate the fact that, when teachers are not just being teachers, but they are involved in the child emotionally as well, and they're more invested, and they are really involved with the learning of the child. So that's really appreciated.